Okay, so welcome back. Let's talk about the size estimation. In the previous page, we provide you with a very simple equation for estimating the size of the results for queries, right? However, in the real world, the size estimation will be more complicated actually, and we have to deal with both the tuples available for the relations and also consider the values available for some attributes. And we also need to consider the operator we are studying. Actually, different operator will introduce different costs for the sizes. So in this page, we will focus on introduce how to estimate the size for the queries and the result. And so we need to have a size in order to estimate the cost for the operation before, right? And we have some examples, like the cost for the partition-based hash joins between E1 and E2 actually will be equal to 3b E1 plus 3b E2, right? This is what we learned from the previous pages, for the query processing, this section. We know this cost will be about 3b E1 plus 3b E2. This notation denotes the number of blocks for storing the relation E1 as well as the number of blocks for storing the relation E2, right? And BE1 and BE2 equals to the number of tuples TE1 divided by block size and TE2 divided by block size, right? So this is for the hash joins. And also we need to estimate for the TE1 and TE2, so we will be able to estimate the cost for the joins between E1 and E2, right? And besides the joins, we can also estimate the size for the results of some other operators, like a selection, for example. Let's assume we are studying a selection of the selection A equals to C. A is the attribute, C denotes a specific value on the relation R, and we can define the result to be this S relation. And we know the size of S or the result can be in any value from 0 to TR minus VRA plus 1, right? I hope you still remember this VRA denoting the different the unique values available for the relation for the attribute A, right, in the relation R. So for the selection, the lowest number for the result will be 0, because if we cannot find any tuples matching this condition, then the result will be empty, right? Empty state or empty relation. So therefore TS for the result can be 0, and the maximum value can be what? So we need to consider different values available for the A attribute, right? And the maximum value available for S, for the selection result, it will be equal to actually, we can assume for all the other values except C, right? They all have one single tuple in the relation R. If so, then we can assume the largest result for returning by selection operation will be equal to TR minus VRA plus 1, right? This VRA denotes different values available for the A attribute. If all the remaining, different values, they only have one single tuple, then all the relation, all the other tuples will be, returned as a result, right? So this maximum value will be equal to this term as we show here. As to the mean value for the result, we can denote the mean value of the TS to be TR divided by VRA. We assume all different values for the attribute A, they have the equal number of tuples in the relation R. This is one example. Another example we can have here is for selection A is less than C on the relation R. We define the result as S. This TS or the size of S can be any value in the range from 0 to TR. And we also have a heuristic, TS can equal to TR divided by 3, for example. So, this is the size estimation for the selection operation. And we can also show you some concrete examples in the next page to show you, how to calculate the score, to calculate the size for the return results on the joins as well.